We have studied about one question we have studied. If we are having infinite line charge, and it is having a charge density of lambda, having positive charge, what will be the formula of electric field at a distance r from the center? We have studied E is equal to lambda by 2 pi epsilon naught r. We have derived this formula also. Remember? So, based on this, we have to do one question. Try one question. You please try. I've give you 15 seconds to try this question. Please try this question once. Please try this question. Try this question once. It is telling that an infinite line charge produces a field of 5 megacoulomb. That is E is given. In this question, I am doing the solution. E is given 5 megacoulomb, 5 mega newton. That means it is given 10 to the power 6 Newton per coulomb. And it's also telling that R is also given at a distance of R is equal to 0.02 meter. We have to find charge density. Remember, charge density for infinite line, it means lambda, linear charge density. So it is asking about lambda. We know that we have formula of E is equal to lambda by 2 pi epsilon naught r. We have to find this lambda. All things are given. We can find. One trick is there. What we have to use here? Remember, when we are calculating lambda, what we will do? E is given. What is E? E is given this much, 5 into 10 to the power 6. And when we are multiplying here, 2 into pi epsilon naught r, what we will do? We will multiply here 2. We will divide by 2 and multiply by 2. It will become 4. And now we will use the value of 4 pi epsilon naught here directly and solve the numerical of this time. Okay? And you can put all those values and you will get the answer in Newton. So I think we will get in answer in coulomb per meter. Okay? Any problem? This was just a question to remember the previous concept, last concept which we were learning. Only for that. Any problem till now? Can we move further? Okay, nice. Now, let us move further. Let us move further. Second application of Gauss law. If we are having infinite plane sheet, that means infinite plane sheet, it means like this. If we are having an infinite plane sheet, remember these are the very important application of Gauss law. Just think a sheet of paper in a book, one sheet of paper like that. If it is having suppose charge positive and the surface charge density is sigma. Let us suppose this is a charge present on this sheet and it is infinite shape. That's why I have made the boundary like this, because it is infinite. Now, to find the electric field at any point, let us suppose at a distance r from the sheet, I have to find this electric field here. According to Gauss, what I have to do? I have to draw any surface which is easily for me to calculate its area or other things. I suppose here one surface like this, which is cylinder, which is touching this point also. And also remember, one cylinder is also possible at the back side, because similar point will be present symmetrical. Due to symmetrical, this point will be symmetrical to this point. That's why I have to consider two cylinders. Now, when I am considering this cylinder to find the electric field at this surface, electric field will be in this direction. And suppose area, I say dA, small area dA. Area dA will be this side, perpendicular to a surface. Here, electric field will be this direction E, and also dA area, small area dA, it will be outside like this. By Gauss law, we can say that close integration of E dot dA is equal to charge enclosed. That means charge enclosed by epsilon naught. Let me calculate it first. E into dA. When we are looking at this surface, here we can see that E and dA both are parallel. E and dA both are parallel. We can write it like this: E dA, E dot dA. That means E dA cos is 0 here. We can write E dA plus. For this, we can write E dA. And for this curved surfaces, we know that area will be this side, dA, and elective will be in this side. So it will be perpendicular. So for these curved surfaces, it will be product will be 0. So we have write 0 here is equal to Q enclosed. What is the Q enclosed in this cylinder? In this cylinder, you can see that only the charge enclosed is here only, which is a touching part of the plane surface. What will be the charge enclosed? Let us suppose its surface density is sigma. So surface density, we know that sigma is equal to charge by area. So charge is equal to surface density into area. That means we can write it like this: surface density sigma, and area we have assumed as dA. So we can write it as like this dA. What it came to be? It came like this: E twice of EDA is equal to sigma into dA. dA cancel. We can write from here E is equal to sigma by, we can write like this. Oh, okay. One thing missing here, na, epsilon naught. Epsilon naught missing here. We can write like this: E is equal to 2 by sigma epsilon naught. And this is the formula of electric field at a point from a thin sheet. One thing, important thing which we should remember is that it is independent of R. It is independent of R. So at any point from the plane surface, here, anywhere, it will be constant, because sigma is also constant and this is constant. So it will be constant always. Remember this thing. Important point to note, that it is independent of R. Now, based on this, one more application is that if suppose we are having a bunch of sheet. Let us suppose bunch of sheet means a thick conductor like this, having some thickness like this. Suppose a book having some thickness. It was a page. That means it was not having any thickness. Let us suppose it is having a thickness. And for this, we can assume what we get. We get E is equal to sigma by epsilon naught. We can derive also, but not necessary. We should remember for a NEET exam that for a thick sheet, for a thick conductor or sheet, which is charged, okay, thick charged conductor, for this E is equal to sigma by epsilon naught. It is double of it. How we can remember? I am telling you one trick. How you should remember. Let us suppose when we are looking from here, this side, this, how we can see that we will see the thickness of this conductor. That means we will see positive charge here, because we know charge is always present at the surface of the conductor. So for this, we know if we try to find electric field at this point, what we will get for this surface, it will be sigma by 2 epsilon naught, and for this surface it will be sigma by 2 epsilon naught. So for a thick conductor, we will get net electric field of sigma by epsilon naught. Similarly here also sigma by epsilon naught. This is just a trick to remember. Okay, by this way you should remember. And also the derivation is also present, but we are not considering the derivation, because we are preparing for NEET exam. That's why. Any problem till now? Okay, so let us move forward. Now, this is a good question, very good question, very good question. I give you 30 seconds to read it once and try. 30 seconds. Take 30-second time, read it and try it once. Take 30-second time. It is stating that two metal sheet. Try 30 seconds. I'm giving metal sheet. Okay. It is telling metal sheet. Try 30 seconds. Now, no worry. Any answer? Okay, no worry. It is telling that it is having a two metal sheet parallel to each other, like this, parallel to each other, and they are sheet. Remember, sheet. Whenever you see the sheet, you remember electric field is equal to sigma by 2 epsilon naught. Okay. Now, they are parallel to each other, having equal and opposite charges. That means if it is having sigma charge density, it will have minus sigma charge density. Now, it is telling that their opposite charge density of and the charge density is also given. Sigma is equal to given 0.17. Pico means 10 to the power minus 12 coulomb per meter square. This is given. Now, what will be the electric field? Okay. This is a mysterious question. Electric field, we have to find the electric field in between the field here, right side and left side. Three reasons. First reason, second reason, and third reason. Now, for first reason, we are calculating for first reason, reason 1. What will happen here? Here, for this charge density, that is plate A and plate B. For plate A, electric will be outside like this, sigma by 2 epsilon naught, and by charge B, plate B, it will be inside like this, electric field, and it will be sigma by 2 epsilon naught, because we know negative charge, electric field enters into it. That's why electric field will be inside. So for the outside, what we will get? E out. Here, what we will get? Sigma by 2 epsilon naught plus minus of sigma by 2 epsilon naught, that will be 0. And similarly for third also, E out will be 0. We can see here, for this B plate, electric will be this side, and for A plate, electric will be this side, and net will be 0. Now, second reason, in between the two plates, what will it happen? For plate A, electric will be this side, electric field will be this side. It will be sigma by 2 epsilon naught. And for this plate B, electric will be towards B, that is sigma by 2 epsilon naught. This is away from A, and this is towards B. Okay. What will be the electric field? We will say that electric field inside will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught. What we will get? We will get sigma by epsilon naught, and you can solve this. You can solve this and you will get the answer. Any problem till now? Any problem till now? Any problem? We can say here, look after this. Okay, any problem? Okay, good. So remember, we will be using this similar concept in chapter capacitor. So remember, there we will recall this once. Now, let's move further. Second concept is, third application is that charge spherical cell or charge sphere. If we are having some charge sphere like this, it is having some charge. We know if it is a charge sphere conductor like this, then charge will be outside the sphere on the surface. Now, when we are talking we are talking about like this. We compare like this. Till this, it is having a radius r, and outside this, it is varying like this. And we say at any point, let us suppose here P, and it is at a distance of r from center. When we are trying to calculate electric field outside, first let us calculate electric field inside point. Inside point. Let us suppose assume this point as P1. P1 point is here. Suppose P1. We know according to Gauss, we have to draw one surface here like this. Let us draw the surface. What we get? We get E dot dA is equal to Q enclosed by epsilon naught. We can see that the charge enclosed will be 0 because inside the conductor there is no charge present. So 0. That means electric field will be 0 inside the conductor. Remember this thing, very important. Inside the conductor, it can be a spherical shell or sphere. For both of them, inside the conductor, inside this, electric field will be 0 always. Now, if we are calculating second outside point, for outside point, what we get for outside point? Let us draw for outside point. Let us draw like this Gaussian surface like this. We know E dot dA is equal to Q enclosed by epsilon naught. What we will get? We will get electric field at this point. We have to find electric field into what we do, into area of this sphere, this one, capital big one, this black one. Area, what we will get? We know sphere area is 4 pi r square. We write like this. Now, charge enclosed. Let us suppose surface density is sigma. We say sigma into, we know charge is present outside this surface, and the surface area of this red one, original sphere or shell, it will be 4 pi r square like this by epsilon naught. And similarly, we will get here electric field, some electric field here, and it will be like this, something like this. What we are getting? We will get sigma and all, we will get cut here. What we get? We get sigma by epsilon naught like this. I think some part I think dA here, and charge enclosed is taken like this here, 4 pi r square, and here it is taken as 1 minute. What E into, this is area of the Gaussian area like this, and the charge enclosed is sigma into 4 pi r square here by epsilon naught. What we are getting here? We are getting remember one thing, 1 minute. Sorry. Now, what we are getting here? Okay. Now, what we are getting here? Sigma, like this, sigma into okay. Now, what we are getting? Sigma, all cutting here, cut here. What we are getting? For sigma r square into r square. We can write sigma like this. We can write here, put value of sigma. Sigma is equal to charge. Sigma is equal to charge into area, that will be 4 pi r square. I should not put like this. I should have put only Q here. Then calculation will be very much easy. So if I put here only Q in place of this, it will be a very useful, very easy. E into 4 pi r square is equal to charge by epsilon naught. Then E will be charge by 4 pi epsilon naught r square like this. Or if we have put this value here, same value we will getting here. Now what we are getting here, this means that outside point, for outside point, electric field is inversely proportional to r square. Now two important conclusion we have got. Now we will try to plot this. How we will plot this? Now let me show you, because I am not dealing with a derivation part, that's why don't bother about it, because it is not very much important. Now important part is this. You can see here, if it is a conductor, now when we are dealing here, let us suppose this is r. We know when we are calculating electric field, we know inside this sphere, electric field is always zero. Electric field is zero like this, zero. And at the surface, electric field will be, we can see in the previous page, at the surface, electric field we have to find. We will put R is equal to R. Then what we will get? We will get E is equal to Q by 4 pi epsilon naught R square, like this. So on the surface, we will get what we are getting. We will get Q by what we have calculated here. You can see what we calculated here, Q by 4 pi epsilon naught R square. After that, it will be decreasing with the equation like this. Electric field is inversely proportional to R square, and it will be varying like this, parallel. Okay, this is the curve of electric field, and similar curve you must have studied in chapter of gravitation also. You must remember similar. Now let me show graph for electric potential also. Electric potential. Let me show electric potential. How does it vary? Now for electric potential, we know that for a conductor, inside the conductor, electric potential is constant throughout. And what is this? It is Q by 4 pi F. You know, it is constant throughout. After that, it starts decreasing like this, with relation of V is inversely proportional to R. It is R square and it is R. Okay, you should remember this. It can be a sphere also, or for shell. For both, it is the same relation. You should remember this. Any problem till now? Because I am dealing with a part which are asked in NEET exam. That's why I'm not focusing on those section like this derivation part. Okay, good. Actually, I'm also having some cold problem. That's why I'm facing a little bit difficulty. Now, let me move further. Now, okay. Let me take one example first. Good example. Then I will move further. Let me take one example. Good example. Now, let me take one question. Good question. Now, if we are having like this conductor, or let us say a conductor with cavity having charge. It is given like this. There's one conductor and there's one cavity. It is cavity, and one charge is placed here, that is capital Q. And you have to draw electric field. Now, draw. I give you 10 seconds to draw. You try first. 10 seconds. Take 10 second time and try to draw. This is cavity in between. This is cavity. Don't get confused. No material, air is only air present. Tried all of you? Now let me discuss it. Suppose it is given plus q charge here. We know if it is plus q here, then minus will be here. This will be minus q charge, and if it is minus, then plus will goes to surface like this. You remember, charge cannot be present inside the conductor. So here outside this hollow sphere, this surface, and outside this surface here. So how will electric field occur? Electric field originate from this charge plus q and from center like this, that's it, like this, and it will vanish here and will come out like this, come out like this, come out like this. This will be the electric field for a charge within a charge for a conductor having cavity. Okay, there is one proof also, but I'm skipping that proof because for NEET exam I don't think so much details is required. That's why. Any problem? Understood this question? Similar type of question can be asked in your exam. Okay, any problem? Problem? Please you write a problem, no problem, because yes, no, I get confused always. You write problem, repeat like this. You should write clearly. Okay, okay, nice. Okay, now let us move further. Let us move further. It is telling that non-conducting sphere or uniformly charged sphere, it is given. Now this is an important part. You should remember, I will not go to a detail of it, very much detail, because it is important for JEE people. Now if suppose somehow it is telling that there is a charge on the sphere and it is uniformly charged, it is not conductor, it can be insulator, it can be a non-conducting sphere, insulator also, and the charge is present throughout the volume everywhere like this, and then we have to find the electric field. Remember, for this also outside point will be same behavior. For outside point E out will be same like this, 1 by r square. No worry, same relation. We have to find only inside point, for inside point. So for this, what, since the charge is distributed in the volume, so we have to consider volume charge density rho, and it will be charge by, if suppose it is having area of r, then 4 by 3 4 pi r cube. You remember, this is volume of sphere. Now if we calculate the electric field for this inside, what we will get? We get at any point inside this, we get electric field is directly proportional to r for inside point. For, let us suppose, any distance from here, I am telling naming is like this, r in. It is directly proportional to r in, like this. There is derivation also, but I am skipping the derivation. But if you want, I can derive here also. That depends upon you. So for conducting sphere, we can say that it is like this. Electric field is like this. First proportional, increasing with it, and now after that decreasing like this. Outside relation is 1 by r square, and inside it is directly proportional to r in. This is the electric field diagram. You should remember. Any problem till now? If you want derivation, you can tell me. Otherwise, I will skip the derivation because it's not important so much for your NEET exam. Any problem till now? Any derivation you want? Okay, I'm skipping the derivation, so don't worry because it is not important for the exam. That's why we are focusing on NEET exam. So I'm skipping the derivation. Now, let me discuss one more thing. Now, let me discuss a few more things. One question. One question. Suppose it is given that we are having, suppose it is given that there is a hemisphere. I am taking some question example. Hemisphere, it is a hemisphere having radius r. One charge is placed here q. One charge is placed here q, and it is telling that find electric flux through surface of hemisphere. You try once. I am giving you 10 seconds to think. It is a hemisphere and one charge is present at the center of this. Here, you have to find the flux through the hemisphere surface of hemisphere. Try. I give you 10 seconds to think. Okay, no worry. Let us discuss here. Now, how to do this question? We will think if it will be the whole sphere like this, because we know that Gauss law tells about the closed surface, not open surface, because if it is a hemisphere, it is an open surface, but Gauss law tells about the whole surface, it is a closed surface, and we call it as a Gaussian surface. And we know that it is E dot dA, that is integration of flux d phi, closed integration of flux, and it gives us enclosed charge by epsilon naught like this. Now, first of all, let us assume it as closed whole sphere, pura sphere. We had assume it like this. It is a whole sphere. If it is a whole sphere, what we will get? We will get flux is equal to charge enclosed. Charge enclosed is capital Q by epsilon naught, and flux will be phi is equal to Q by epsilon naught. But it is not a closed surface, and we are getting it is only a half surface. That's why we have to divide factor by 1 by 2. Since it is a half, we will get what we get, new flux. From here, we will get phi is equal to sigma charge by epsilon naught. But since it is a hemisphere, half of it, and we know if it is a hemisphere, the area will be, surface area will reduce to half. So a factor of 1 by 2 multiply here. What we get? Sigma Q by 2 epsilon naught. This will be the answer. Any problem in understanding this? Any problem? Okay. Now let us move further. Now, let me take one example also, and try to give you one question. Now, if suppose it is given that, we are having a cone like this, cone like this. It is having a cone, and for this cone, let us suppose a charge is present here, and you have to find flux through curved surface. Can you tell me what will be the answer? Can you tell me what will be the answer? How will you think? Can you tell me what will be the answer? Zero. Look, calculate from here. Think like this. Think like this. You can remember. No problem. It was similar. If suppose I give you hemisphere like this, will it be zero? No. Similar concept. We will complete it like this. Similarly, what we will do? We will assume it like this and complete it like this. And we will think that flux is equal to charge enclosed by epsilon naught. We will get flux is equal to charge by epsilon naught. But since it is half of this cone, if we draw one cone, then the charge will get enclosed in a closed surface. So since upper part is not present, we will say flux is equal to Q by 2 epsilon naught. Remember. Any problem? Getting difficulty to understand? Any problem? Facing any problem till here? Any problem? Okay, good. Now, if you got it, one more question, similar like this. I think it is a famous question. Suppose we are having a square of side A. It is a square of side A like this, and charge is present. Q charge is present at a distance of A by 2. You have to find the flux. Find the flux through this square plate, square surface or plate. Will you try? Try once. Give you 10 seconds to think. Any answer? Can you try? Can you try? Any answer? Can you try? Okay. No worry. Not getting any problem. No worry. Now, let us discuss this. What we will do? It is given that we are having this square and one charge here. What we will do to apply the Gauss law? Remember, to apply this Gauss law, what we have to do? We have to close the surface. Then we can apply this Gauss law. And after applying this Gauss law, we will manipulate this flux according to our requirement. Okay, this is the step. So for Gauss law, we have to make the surface closed. So what we will do? We will make a cube using this. What we are doing? We are making one cube like this. We are making one cube like this. We have made one cube like this. Okay, cube having 6 faces. Now for this, it is a closed surface. If it is a closed surface, we can apply Gauss law, and we will tell that integration of d phi is equal to Q enclosed by epsilon naught. Now Gauss law is valid here. So what we will get? We will get flux is equal to Q enclosed by epsilon naught. This is for the cube. Now for one surface here, for this we have to find for this. What we will say? Now we will manipulate according to our requirement. So for one of the square, what we will do? This is for the 6 faces. Cube has 6 faces. For one face, what we will do? We will multiply the factor of 1 by 6 Q by epsilon naught, and this will be the answer. Any problem, any confusion till now? Any confusion, any problem? We can discuss once more. Okay, getting now? Very good. Now, let us move further. Let us move further. Now, since till here, we have ended our first chapter, that is electrostatics. Now we will discuss questions today or tomorrow also, and we will be starting our new chapter, that will be capacitor. Okay, now let us discuss some question. Now you find what it is. You try once. It is telling the potential gradient is a. Try once. What is the question? Try once. Potential gradient is. You remember what is potential gradient? That means dV by dr. And you know, in electrostatics, dV by dr is electric field. You remember, electric field is scalar or vector? Electric field is scalar or vector? It is a vector quantity. So, in electrostatics, potential gradient is a vector quantity. Remember, first important point. Second important point, what will be the unit of potential gradient? If question comes, what is the unit of potential gradient? Unit and dimension. Can you find unit and dimension of potential gradient? What will the unit and dimension? Can you tell? Unit will be volt per meter. And you remember, when I was discussing electric field in my previous lecture, I was telling that I have written there unit of electric field like this, Newton per coulomb and volt per meter, and I told you that we will study about this. From here only we write the unit of electric field as a volt per meter. And similar, you can find the dimension also, dimension of potential and dimension of length, distance. Similarly, any problem? We move further now. Okay. Let us see. Yes. Now, this is one question. I give you 10 seconds, 30 seconds. Then you should try. This is a good question. And remember, these are the questions which are as or asked in your NEET exam, or they are very much expected question, that the similar type of question comes usually in your exam. So try, take 10 second, 30 second time, and try once. Try this question once. Try this question once. We'll discussing this question. Okay, option A. Okay, good. So fastly, good. Let me do. It is telling that electric potential at a point is point is given like this. I think x y z like this. Okay, x y z. V is equal to 4x square. Potential is given. Electric field. Okay. Then we find that E is equal to like this. You do minus dV by dx like this, and you got minus 8. I think I like this. I think minus 8x, and you put here a value of x as 1 meter, and you got minus 8. Okay. Good, good, good. Answer will be A only. Good. Now, let me take one example from a similar type of question. If suppose I am having this electric field and I am having 3 points like this, A, B, and C. A, B, and C. And if I am telling you that, can you show me what will be the relation between potential at B, and C? Can you tell me what will be the relation? Option A, option B, option C, or option B, option C, and option D will be none. Can you tell me what will be the option? Okay. Option A. Or I have written wrong. It may be wrong also. Nobody. Now, Nandi, you did mistake here. I think. Now, if you are telling here, remember one thing. We have studied in a previous lecture that we have learned in a previous lecture. You may remember in direction of electric field. In direction of electric field, potential decreases maximum. Potential decreases maximum. It was the note point to remember. You can see in direction of electric field, more movement is here for C. So we will say that for C point, potential will be very less. For B point, potential will be more. And for A point, potential will be in between this. So relation will be VB greater than VA greater than VC, like this. Least potential for this, which are moved here in direction of electric field, that point will have least potential. Okay, answer will be none. Any problem? If you are facing problem, you can ask. I will take one more example here. And I think I have one question from your exam also. In your paper, it has been asked. Okay, so got it. Okay, nice. Okay, good question. You should try this question once. Try this question once. I give you 30-second time. You try this question once. You try this question once. It is telling okay. Variation of electric field intensity E with EX curve is there given. Sorry. Any answer? Try once. Try. Okay, got the answer. How to solve this? Okay, nice. No. Okay. Now, I tell you. We have to find the potential. Okay, now what is the potential difference now for this type of question? Let me take one thing. We know dv is equal to minus E dot dr, like this. We can say this is a potential difference, that is final potential minus initial potential is equal to minus of E dot dr. Or we can say, if we take minus sign this side, we will say V initial minus V final is equal to minus of minus when there 40 volt. Okay, okay. Let me see. E dot EDR. Remember this? Now, from here, geometrical meaning is that area under, area, we can say like this, area under ER curve. ER means electric field at distance curve. Area will give what? It will give this. So remember, if one conclusion and second also we know E is equal to minus dV by dr. So we can say that slope of VR curve, it means that slope of VR, it can be VR, Vx, Vy, Vz, anything. VR means either Vx or Vy or Vz, any of the three. R can be X, Y, Z. If we take slope of VR curve, it will give electric field. So remember, using the graph, if we take slope of this curve, it will give the value of electric field. And if we take the area of ER curve, it will give the Vi minus Vf product. Vi minus Vf, difference of initial minus final. Now, let us move to a question. This was the theory part. Now, if in this question, we can see it is telling that the potential difference between the 2 and 6. Now, for 2, here it is 2. ER curves, see E and it is given R. R is X here. For ER curve, if we calculate this area, it is electric field at 2 meter. What it is coming? We know triangle area half into base into height. It comes to be 10 Newton per coulomb. Now for 6 meter, from O means 0 here, original point. Now for this 6 meter, it is telling now we have to take area of from here, whole area. We know for trapezium we are finding the electric field at 6 meter. Sum of parallel sides, that is 0 to 6 and here 2 to 4. We can write 6 plus 2 into height. Height is 10. We can write here 5. We get here 40. But remember, question is telling what is the potential difference. At this point we got 10. It is 10. We are calculating a potential V. Sorry, not E. V. This is volt. This is volt. 10 volt here, and here we got 40 volt. So we have to find the difference, and difference will be 30 volt. Okay, we have to find the difference. If it was asking for 6 meter, then answer will be 40, but difference will be 30. Any problem you can ask once. Any problem you can ask once. Any problem you can ask. Okay, nice. Now, let me take a similar question here, because I think I may not miss this question. I think I've not got this type of question. Now, if suppose it is given like this, like this. Okay. I think it is it is like this. Now let me draw very precisely. Now, it is a straight line. It is 10. It is 4. And it is 10 meter. We have to find electric field at equal to 10 meter. Can you try? Once it is a straight line, it is a straight line. It may appear some curve because I have drawn by free hand. So, can you try? I give you 10 seconds to think. Only 10 seconds. Similar type of question using the graph. Can you try? Try this question. Okay, no worry. Now, let us discuss. No worry. Let us discuss this question. No, we know for VR curve, if we take the slope, we will get electric field. Now, if we are trying to take the slope, to find the slope, what we do? We draw one triangle here. We take this angle theta and find the tangent of this angle, tan theta. So for tan theta, we have to find this value. It is 10. For it will be 6. 0 to 10, that means 10. So tan theta will be 6 by 10. And this is the slope, we know. And we know slope of electric field is E. So E will be minus of 0.6 volt per meter. Any problem? Any problem? Any problem? If you think, actually I think, sir, okay, good. I'm explained again. Now, what I did here, you see what I did here. I was telling that, it is given like this VR curve. VR, it can be Vx also, Vy also, Y also, and it is given a straight line. We have to find the electric field. We know that electric field is slope of this curve, VR curve, Vx curve, or Vy curve, anything. Slope means if it is a straight line, to find the slope, what we do? We take tan theta to find the slope. Tan theta will be perpendicular by base. We made this triangle using this curve which was given to us, this straight line. We made a right angle triangle here, like this, right angle triangle. So for this right angle triangle, we take the tangent of this, perpendicular by base. Perpendicular is 6, base is 10. This is a slope, and we know slope gives electric field. So we will say that slope is equal to, we are getting 0.6. We have to use minus sign here because formula we have minus here. So E is equal to minus 0.6 volt per meter. If you want to know from why we are putting here minus sign, one answer is that because from formula. Second is that by concept, you can see here at 10 meter, potential is increasing. That means at this point, electric field must be in opposite direction, because potential can't increase in the direction of electric field. Since potential is increasing, so at this point, electric field will be in opposite direction. That's why to show the opposite direction, I have applied here minus sign. Any problem? Got it? Or shall I repeat it once more? You got it? Any problem to anyone? Okay, nice. Remember, these are important type of question for your exam, because for JEE people we teach a lots of variety of this question, but for NEET some of a variety like this only question came. So we are considering this type of questions. I'll come for your also. Now read this question and take 5 seconds and answer the question. It is just a theoretical concept. Answer this question. Answer this question. You can see, answer this question. Any answer? Any answer for this question? Okay, no worry. Let me answer this. Let me answer this. No worry. No worry. Let me answer. Understand the answer? It is telling that the work done in moving a electric charge Q in a electric field does not depend upon what does not depend. What will you tell? Now, does it depend upon mass? Let us think. Potential difference between the 2 points, magnitude of charge. We know that work done for a charge is equal to potential energy change. We know, we have calculated for dipole also, and we know for any system of charges we have learned about the formula Q1 Q2 by R, and we can see here it is also equal to U is equal to V into Q. You remember this formula? We can compare. It depends upon the potential difference or not. Yes, work done is related with potential difference. You can see potential or potential difference. B can't be the answer. Magnitude of charge. You can see charge is coming everywhere. So charge is also dependent. So all of this not possible. Only mass is possible, because we know that for work done or for charge, mass is important for mechanical work done. What we study in mechanics, where force, acceleration is come through the mechanical energy. For there, here mass is not dependent. We are not depending upon mass. So let us move further. This question, you read this question. This is the homework for you. You have to try at your home. Take a screenshot of it. Take a screenshot. We will discussing it further. You have to try this question. Very easy question. You should try. Will you try this question, or shall I explain it here only? Okay. You will try. You will try. Okay, you must try. Good. That's the spirit. You should try. You should try. Good. That is the spirit. Good. Now, second question. Another question to you here is present. You read this question. Take 10-second time. Think upon it. Think upon it. Then we will solve it. It is telling that 50 joule of work must be done to move an electric charge of 2 coulomb. Charge is given 2 coulomb from a point from a point whose potential is -10. Okay. It is telling that a charge of 2 coulomb, it is moved from one point to another point, second point. At initial point, potential is -10 volt, and at second point, we are not knowing the potential. Let us assume the potential to be V here. Now, the value of V, what is the value of V? Okay. We know, one thing we know, V is equal to U by Q or W by Q. Delta V is equal to delta W by Q, like this. Now, what we will do, work done is given 50 joule and charge is 2 coulomb. Here, it is moving from this point 1 to 2. What we will do, we will find the difference, potential difference, initial to final. Okay, 10. What we will do here, 10 V1 minus. Okay. Answer came. Okay, good. V is equal to minus 15. Good. So let us move further. Next question. Any problem till now? Any concept you can discuss? Any problem till now? Any problem? Okay, nice. Okay. Now, it is given that question you can see electric charges having the same magnitude of, you should read the question first. Take 30-second time. Try it once. Take 30-second time. Any answer from anyone? Okay. Let me see. Okay, it is telling that electric charge Q are placed at here, so on. If two consecutive charges have opposite sign, but the first charge is necessarily positive. Okay, positive here, minus Q, plus Q, minus Q, and so on. That means 16 here, plus, and so on. What will be the potential at here? To find potential here, you tell me. You said 0. Now, since you know, let me see one thing. Because if it is a limited system, you should remember, if it is having a fixed number of charge, let me go to fresh page. Take fresh page. If we are having fixed number of charge, let us suppose 5-10 charges, then at any potential we can say it can be 0 or not. If it not given, it is not given a fixed number of charges, then we should know how to calculate. So avoid telling answer so fastly. So we know V is equal to KQ by R. So let us use this formula and write the expression for it. We can write total potential will be, for this we can write KQ by R will be 1. Another first, now for second, minus Q, minus KQ by 2, then plus 4 plus KQ by plus 4, then minus KQ by 8, then plus KQ by 6, and so on. Now we know if we take K and Q as common, what we get? 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 plus 1 by 16, like this. Got it? What we get? We got here V is equal to K Q 1 minus I think 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 1 by 16, like this. Was repeating. What we do for this type of question, we use a formula of sequence and series. How we will do? We will use KQ 1 positive together 4 1 by 16 and so on, minus one bracket here, minus 1 by 2, you can take common here, it will be 1 minus 1 by 4, then minus 1 by 60, sorry, 1 minus sign taken positive, it will be 1 by 16, and so on. Okay, when you will minus both of them like this, what you will get? You will get V is equal to KQ. You will minus both of them, you will get 1 by 2 and sum of this. Okay, what will sum of this? You will use formula of GP. You know formula of GP. GP formula gives for infinity A by 1 minus R. What it comes? First term is 1 by 1 minus common ratio is 1 by 4. You find here it will be 4 by 3. 4 by 3. That means it sum of one of this will be 4 by 3. That means we can write here 4 by 3. So what we got? This is K is 1 by 4 pi epsilon naught Q 1 by 2 into 4 by 3. You cut this like this here and you will get the answer. Any problem? You can compare. You are getting the answer. You can compare. Any problem till now? Any problem till now? Any problem? Okay, nice. So you should avoid telling answer so fastly. Okay, now let us move further. It is telling that you read this question, take 10-second time and think. Read this question first. Okay, can you do this question? Now, this is given like this, 2Q and 2Q. Now it is telling that potential is 0. Will you do this or I should solve it? Will you try this? I think this is a question is easy. You can try this question. Yes, good. Good. Only you have to write the add up the potential of all those. Good. Very good. Very good. I will give the homework for you. Only you have to write the potential for it. Okay. You have to take one point here, P. Find the distance R. Take A by 2 here, A by 2 here. Or not take A by 2. Just keep it R here. Add up all the potential for this, and equate it to 0. Then you will get the relation between this Q and this Q. You can try. I know you can do. Now, let us move to our next question. Read this question. Take 10-second, 30-second time and tell me, is this question easy? Will you try? Let us discuss this question. If not possible, we can discuss it. Discuss this question. There exists an electric field E in X direction. Okay. Work done in moving 0.2 coulomb charge at distance of 2 meters along the line Okay, it is telling that it is electric field. Suppose here in this direction we are having electric field. Let us name it as E or EX in X direction. And a charge of 0.2 coulomb, it is moving a distance of 0.2 meter along the line making 60 degree with the x-axis. There is one line here, it is making 60 degree here, and a charge Q, that is 0.2 coulomb, it is moving along this line. How much distance? It is telling that distance is 2 meter. From here, it is telling that it is moving 2 meter. Okay, and in moving this 2 meter, work done is 4 joule. What will be the value of E? Well, how to do? First, important, we know that one thing, we know that dV is equal to minus, okay, option D, okay, minus E dot dr. That one thing we know. We know one thing. Also we know that E is equal to, we know that E is equal to minus dV by dr. This also we know. And also one thing, one formula we know, V is equal to U by dV is equal to du by Q. You remember this formula? By using this three formula, you can solve this question. Okay? You can try this question. You can try this question. You know, you can try this question. Good. You have to try. Use this formula and try. Good, good. And also remember one thing. If it is given that it is making 60 degree with it, we should remember here it can be written like this: E cos theta is equal to, you can use this formula also. Okay, and this is general formula. We take cos 0 degree here for minimum change in potential, for maximum decreasing in potential. We take 0 degree. So we write E is equal to minus dV by dr. You can use this formula also and you will get the answer in 2 steps only. I think you will try. Now, we will discuss each question. You only name the, write the number of the question, that number 10, 8 like that, and we will discuss that question. No worry, we will discuss. First you try. That's the most important part of session. Take 10-second time, and this question is also very easy and based on the previous concept only. You read this question. You read this question. Read this question. You read this question. E is given, same question, along x direction, positive charge, move with velocity. Velocity is moved along, you can see. Electric field is along this direction, 10I. Charge is moving along this direction. Potential energy decrease. How much? You see, you find the decrease in potential only. If you find the decrease in potential, you will find, you can comment about potential energy also. One thing you know, in direction of electric field, first you tell, you have any answer or not? First you think, what will be the answer? I will tell you the concept. You have to come to the answer. I will tell you the concept. One concept, important concept. One important concept. Let me tell you. If electric field is present here and we are moving from one point to this point, or this is suppose initial point, like this, okay, all electric field, and this is third point, 3. If suppose first, let me discuss. If person A moves from 1 to 2. Remember, the person is moving along the electric field. 1 to 2 is along the electric field. 1 to 2 is along the electric field. So, in this case, decrease in potential. It may be energy or only potential will be maximum if we are moving. Second, if person B moves from 1 to 3 and this is perpendicular like this, so for this potential decrease will be 0, no decrease. Potential will not change. So if we are moving perpendicular to electric field, potential will not change, and if we are moving in the direction of electric field, it will decrease maximum. But remember, this convention is only for if we are having positive Q charge. The convention will become opposite for minus Q charge. Okay, that we will see when question comes. Any problem till now in today's session? And with this concept, you can go through the question, and with this concept only, you will get the answer of the previous question. You will get the answer. You can find the answer by your own, and we will discuss. So for today, we are ending the session, and tomorrow's session will be very much important. We will discuss only questions that is the most crucial part of physics, and it will be very useful for a NEET exam. So tomorrow, join on time. Don't be delay a single minute also. Okay.